Hello everyone, this is CS Wave, and today I'm going to be going over the Red Knight's shortest path problem on HackerRank. This is for the World Codesprint 12 contest. It's a 2D graph problem, and I thought it was kind of interesting, so I'd make a video about it. I'll link the problem below, so if you haven't done it yet, you could try it out before watching this, and yeah, I'll get into it now. So the problem is basically, you have this node in a 2D grid, and it has 6 different kind of moves: upper left, upper right, lower left, and left, as shown in the picture. And you're given the starting and ending coordinates, and you want to find the shortest path using these moves from the start to the end. Also, there's a priority of moves given here, so the priority is upper left, lower left, and left, because in many of the cases the shortest path can have a lot of different path sequences, but there's only one answer that would be right using the priority. So I'm just going to comment the priority here for later use. So an example would be the input 7 by 7 square given the 7, 6, 6 being the start, 0, 1 being the end coordinates, and the output would be 4, which is the length of our path, and then the actual sequence of our path. So upper left, and left, as seen in this picture, making 4 moves. Pretty simple. Another example would be this one, where, as you could see, there is no possible way to reach the end, so it outputs impossible. So this is an example illustrating the priority. So there could be 2 different possible paths for this. It could be lower left, lower right, or lower right, lower left, but since lower right has higher priority, you have to output lower right. So yeah, when thinking about problems like this, you might think of using like breadth first search to find and backtracking to find like all the possible paths, and then picking the shortest one. But that gets kind of complicated and annoying, so I just thought of it as a simple graph problem where you have a start coordinate and end coordinate, and imagine that the node only had like 4 different kind of moves, just up, down, left, right, like normal. How would you find the shortest path? You would just take the difference of the columns and difference of the rows, and depending on that, output a path, just going up, down, left, or right. So I kind of took that, broke it up into a smaller problem, and then expanded on that. So starting off, I would want to find the row difference and the column difference of our coordinates. So start off by defining that, the row difference. Also, yeah, I'm using Java. You can use whatever language you want. It should be the same sort of implementation. So I want to find the row difference and the column difference. And okay. So now given that, we can say, okay, if our row difference is positive, we know that we have to go up to decrease the row difference, like subtracting from the grid. And if our row difference is negative, we have to go down. So going like lower left or lower right. Also, I should note that in the impossible case, since we're always moving up twice, there's no possible way we could land on something that is like 2 or like 3 or 1 spaces above our node. So basically, if the row difference is not even, there's no possible way we could get to that space. So right off the bat, we can write an if statement saying if our row difference is not even, so if it's not divisible by 2, we can just print impossible and end there. Let's probably capitalize this. So, but if it's not, we can go into our figuring out of the path. So given the priority, you want to keep track of what moves you make. So for example, in this example, there's really, your output of moves can be in any order. If there was no priority, so it could be like left, upper left, upper left, upper left, or whatever you wanted to do, upper left, left. So my thought was just to keep track of the moves that you're making, just keep like a counter for every move that you make. And then at the end, depending on the amount of times you use that move, just print that out. So I'd make a variable for each possible move, setting it to 0, and then every time I use that move, I'll increment that variable. So I'll just copy this 6 times. Yeah, and then just change this. Okay, so first things first, if our row difference is, as I said earlier, if it's positive, we have to move up. So I'll start by checking if our row difference is, it doesn't matter if it's 0, so I could just do equal then, or greater than. So while it's not 0, we want to continuously move up in rows. So we could check here if our, okay, since we're moving up, how do we decide if we're going upper left or upper right? So now we check the column difference. So like in this case, so our column difference would be 4. So it's positive, so we have to move left to the negative. So we would want to choose upper left. So we could check, okay, if our column difference is greater than or equal to 0, we increment our upper left and subtract our row difference by 2 since we're going up 2 spaces, and then we're going to the left one, so our column difference would de-increment. Also, yeah, the reason I'm using greater than or equal to, because if it's equal, like in this case, well, this is lower, but it's the same sort of thing. You want to do upper left and not upper right. Since the column difference is 0, either move would work, but we're prioritizing upper left. So yeah, so else we just do the same, but for upper right. So we just copy and paste that, and then we would be positive since we're moving to the right. I think that's good. So else we would be moving downwards. Can copy and paste this code. It's mostly the same. Okay. But so the prioritization is lower right instead of upper left, like right. So we would just swap some of the symbols here to make it lower right. This would be plus equal to 2, and this would be plus. And then do the same here. And then change this to lower left. Okay. So now that we're done checking if we have to go for our up and down, now all that's left is left and right. So we could just check if our column difference is greater than 0. That means we have to move to the negatives to the left. So while our column difference is less than 0, or greater than 0, I should say, sorry, our column difference is 2 less, and then we will add a left counter. Else we do the same thing but for right, and just switch the comparison, and all the, yeah, it changes to right. So column difference plus 2 looks good. Okay, but so for example, if our starting and ending were right next to each other, there's no possible way we could reach there since left and right move 2 spaces and not 1. So while if it goes over 1, so if it goes over 0, if it's not equal to 0 after this, we know it's impossible, because it would be moving to the left in this case. It would hit -1 if it was impossible. So we do a check here. If column difference is not equal to 0, we just print impossible and then return so now we want to print the size of our path, so we could just print out all of our counters here together. So yeah, just copy and paste that, add addition symbol instead of a comma. And now that we have all of our counters, we can go through all of them and just de-increment them, and at the same time add them to a string builder. So I'll create a string builder named result that we will append to, and just go through every possible move, starting with our highest priority, and de-incrementing that, as well as adding that to our string builder. And I'll do the same thing 6 times for all the moves. 1, 2, 3, 4. Okay. So upper left, upper right, right, lower left, and left. Okay. Just have to check the syntax on everything again. Also, we want a space after to separate them. And then lastly, just removing the trailing space. That would be at the end. So result.delete char at result.length -1. And then we could just print our result path. Okay, now I'll check if there's any syntax errors. Probably is. Yep. 67. I did minus, okay. Call. What did I do here wrong? Call diff minus minus. Call diff plus plus. Oh, whoops. I have all these as UL. I am not smart. Okay, so yeah, also change the syntax on all these. That should work, hopefully. Okay, all the test cases work, so I'll submit it now. And there you have it, 100% score. So yeah, that's really it. It's a simple way to solve this problem without using breadth first search or any complicated searching algorithm. You really just go through it like you would in a normal 2D grid, given the difference in X and Y. So yeah, that's really it. I'll post the the code in the description below if you want to try it out yourself. And thanks for watching.